your check of understanding. Just gonna go over this for those of you who didn't finish. Not complicated of a task, but the one thing you have to decide is how you want to write your unit rate, and it really doesn't matter. It's whatever you're more comfortable with. So I'm gonna use two examples, and I'm gonna make one up. So let's say, I guess I can put myself into the group here. So let's say, oops. Let me put this, in here. So let's say I run, I don't know, 3/4 of a mile in 8 minutes and 45 seconds. Right, just two. Right. So the first thing you have to do, I'm running a, starting a running club, and that's my time. Now, 3/4 of a mile, 8 minutes and 45 seconds. So you have two choices. You're either going to find the unit rate, my unit rate, in two ways. You're either going to write it like this, 8 minutes, and actually allow me to, right off the bat, write this like that. So 8 minutes and 45 over 60, and I can do that in 3/4 of a mile. Now, if I change this to a unit rate, right, it means that I want to find out how much time it's going to take me in 1 mile, and that's what you should start writing, right? The one at the bottom, not on the top, but at the bottom, the 1 mile, because it's per mile, right? So in this case, how many minutes in 1 mile? So let's put it at the bottom. Well, now we can divide this by 3/4, right, and divide the top by 3/4, right? Isn't that how we find constant proportionality? Yeah. So 8 and 45 over 60 is the same thing as 8 and 3/4. So again, 45 over 60. That's right. If you divide by 15, this is 3, and divide by 15 is 2. So 8 and 45 seconds over 60 is the same thing as 8 and 3/4. So in your calculator, or my calculator here, I'm going to put, 8 and 3/4. So as a fraction. I'm going to divide that by 3/4. Or the same thing, multiply by 4 over 3, whichever one you feel more comfortable doing. So and that simplifies to 11 and 2/3 of a minute. So actually, it's not far from truth in my youth. So 1 mile takes me 11 and 2/3 of a minute. Okay, so I can find the unit rate per mile, or, and I'll change colors, if you thought it was more comfortable to do it per minute. So in this case, I'm just going to reverse it. So I run 3/4 of a mile, and it takes me 8 and 3/4 of a minute, which is the same thing as 8 minutes and 45 seconds. Now, the unit rate now is per minute. So how much can I run in 1 minute? So it's a little bit different. So I'm going to divide this by 8 and 3/4, and I'm going to divide the top by 8 and 3/4. So if we do that, 3/4 divided by 8 and 3/4. And if you keep it as a fraction, which is what I suggest you do, it means that I can run 3/35 of a mile in 1 minute. All right, so I'm a very slow guy, I guess. 3/35 of a mile in 1 minute. So you can, and then now let's just say that these following people, Josiah, Elena, Simon, Oceana, Delia, and George, want to run with me. Well, I gotta figure out if their time is the same as mine, right? Because we want to run together. So I'm gonna create one more person, and I'll call it, I don't know, Sam. And let's say Sam went running, and it took her, I don't know, 7 minutes and 12 seconds, and she did half a mile, just, right? So now for Sam, I'm going to do it on the top. Now you got to pick. You want to write Sam's rate as per mile or per minute. I have a preference, and I would rather write it per minute. So I'm going to do it. So I'm going to write hers where the miles on top and the minutes at the bottom. So she ran half a mile and she ran half a mile. Sorry, Sam, right there, half a mile in 7 minutes and 12 seconds. Which we're going to write is 7 minutes and 12 or 60. Right, that's her time. Now let's find out how much she can write. Sorry, she can run in 1 minute. Right, and then I can take that her rate and compare it to mine. So I'm going to take whatever, and I'm going to compare to this. So, same process. How do we're going to divide this by 7, 12, or 60, which you can simplify if you want. And divide the top by 7, 12, or 60, which is the same thing as 1/5. Right? So on the top, we get half divided by 7, and I'll just write 12 or 60 for now. Oops. Sorry. 1/2 divided by 7, 12, I should have just 12 or 60. So we get that, and simplify. We get that in 1 minute, she can run 5/72 of a mile. Not that far, but that's how much she ran. Now you can compare this with that, and then you can determine if she and I can run together. Or she's too slow, or she's too fast, but her time should be the same as mine. So that's your task. These two here, you did on the front page, right? On the reverse side of the book. You found the unit rates either per mile or per minute. And now you got to figure out the unit rates for Simon, Oceana, Delia, and George. I need to see what the unit rate, right? So go through. I need to see this, right? This part here, the unit rate, either per mile or per minute for each of the individuals. And then you need to compare it with Josiah and Elena and see if they could all run together. Okay, that was your task. Now that that's over, let's go for your check for understanding. Go back here. I think this was it. Yeah. Switch. Okay, so here we go. Find the equation for the proportional relationship presented in the table. So it's telling you it's proportional, right? So if it's proportional, and I'm gonna just create a graph here, we know that if I plot these points 2 and 12, 3 and 18, 4 and 24, 5 and 30, it's gonna give me a straight line that goes through 0. Okay, so the concept of proportionality, it doesn't matter who you pick. You have 2 and 12, 3 and 18, 4. So pick any one of those points. You know what? Just to be different, let's pick this point. So the point, and our 0.5, 30, right? 5 is your x value, y is your 30 is your y value. So now, constant proportionality, y over x. So we divide that, and we get 30/5, which is equals to 6. So this is my constant proportionality. So now, if I go back to my table, it does make sense. Look, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24, 5 times 6. So that's my constant proportionality, which also happens. And then I know the table doesn't have what x equals when it's 1, but I can plug it in. When x equals 1, y equals 6, right? So there. So this will be 1. Here's 6 to be my point. If when x is 2, y will be 12, and so forth and so forth. Right, so now, my constant proportionality we just found, let me rewrite it over here, k equals y over x. You can pick any of the points. We got 30/6, 30/5, so if we found the constant proportionality is 6. What's my equation? Well, for proportional relationship, the equation comes in this format. Y equals k times x, right? What are we multiplying every x value here? We're multiplying every x value by 6. So the equation of this line equals y equals 6 times x. So let's give it a name. Now they're asking us if the point 9 and 63, if I were to plug in 9 over here, would 9 and 63 be on this line? Right, so if you continue this table and you write 9 over here, so they're saying when x equals 9, y would be 63. Well, is 9 times 6 63? No, so 9 would not, actually 9 times 6 is 54, so this point is somewhere over here. Is it on top of the line? No, it's not. So there's two ways for you to check. You can plug it in. So if you use the equation, you can say, okay, they're saying that y equals 63 when x equals 9, they're saying that y is 63. Well, if you plug it in, you get, here's the equation. They're saying that y is 63 and that x is 9. Well, is that true? Well, this is 63 and 6 times 9 is 54. Obviously not true. So what does that mean? That means that this point that they're telling us is not on the line, right? Yeah, that's it. All right, so again, we're going through the process again, right, of writing this properly. 124 cookies. It says per pound per 1 pound, so we want the unit rate per 1 pound. So pound goes at the bottom. 2 3/5 pounds of chocolate, and we want to change this to 1 pound. So literally, we're just dividing the top by, right, top by the bottom. So this is divided by 2 3/5. This is divided by 2 3/5, and because we have a calculator, right, so it's 124 divided by 2 3/5. Enter. We can make 47 and 9/13 cookies. So we can make 47 full cookies and 9/13 of the next cookie with 1 pound of chocolate. Again, this is your unit. This is your rate, and this is your unit rate per pound. Okay. Nothing crazy. Which graph shows a proportional relationship? Well, two things we talked about. It has to go through 0, 0. Well, this does. The A, B, C goes through 0, 0, but A is not a straight line, so this is a no. This is a yes. This is a yes. And the last one, it's not proportional because it doesn't go through the origin, so this is not. So explain how you decided whether or not D shows a proportional relationship. So D, line D, does not go through the origin, right? Otherwise known as 0, 0. So therefore, it's not a proportional relationship. Okay. Visually, it's so much easier, right? There's not much. 4. Taylor spent $43.92 on 8 reams of paper. Write an equation to represent the situation. What is the constant proportionality? So we're assuming it's proportional, meaning that every ream of paper was the same price. So let's write this as a rate. So $43.92 gave me 8 reams of paper. Now, because obviously it's proportional, right? Every ream should be the same price. What's 1 ream equal? Well, this was quite simple. Divide by 8, divide by 8, right? So if we divide by 8 and divide by 8, 43.92 divided by 8 is $5.49. That's your unit rate. And if you know your unit rate, right? Unit rate is also your constant of proportionality. Constant of proportionality. Right? So you don't really have to do k equals y over x. Now, think about it, and if you created a table where x represents your reams of paper and y represents your cost, right, think about it. One ream would cost you $5.49. 2 reams would cost you $10.98. 3 reams, I have no idea. 3 times 5.49, it'd be $16.47, right? Now, and if you continue that, you would up to 8, and 8 reams we already know would be $43.92. So if you look at this table, every single x value is being multiplied by what? Times 5.49 times 5.49 times, sorry, I can't write the 49 level. better, but times 49. So there is your constant proportionality. Well, now if it's a if the proportional relationship, when we graph this, it's going to look like this. This guy here is going to be your unit rate, and we can call this the unit rate. And it says, so the unit rate is that when one ream of paper, we buy 5.49. That's what we pay. Here's our point, right? And this guy is our constant proportionality and your unit rate. So my equation is going to look like this. Y equals, what are we doing? What are we multiplying every x value by? Every x value is being multiplied by $5.49. That is the name of this line. Y equals 5.49x. Okay. 5, the relationship of something, the length of the side of a triangle, equilateral triangle, x, and the perimeter of the triangle can be represented on the coordinate plane with a straight line. Determine if the following points are or not on the line. All right, so think about what that means. So let's create an equilateral triangle. So if equilateral means all the sides are the same. So if that's 1, that means this is 1, and this is 1. So when the side is 1, what's the perimeter? The perimeter of that triangle would be 3, right? Now let's create another triangle. Pretend this is 2, 2, and 2. So when the side is 2, when the side equals 2, what is the perimeter? The perimeter would be 6. We draw one more triangle. When the sides of the triangles are 3, so when the sides are all 3, the perimeter equals 9. So we can create a table here. This would represent the side. This would be perimeter. Right? The perimeter depends on the length of the side. So when the side is 1, the perimeter is 3. We just did that. When the side is 2, when each of the sides of the triangle is 2, the perimeter is 6. When it's 3, it would be 9. When it's 4, I'm pretty sure by now you can find the relationship. So what's the relationship here? Times 3, times 3, times 3. So if you drew a triangle and all the sides were 4, what would be the perimeter of this triangle? It would be 12, right? So if you were to graph this, right, this would be the perimeter. This would be the sides, right? Now, so when the side is 1, the perimeter 3. When the side is 2, the perimeter, and again, we'll call this 6, right? And again, it'd be a straight line. Can you find, do we have the constant proportionality here? Do we have, can you, I'm pretty sure you figured that out. Can we write what the equation of the line? Y equals something x. What are we multiplying every x value by? We're multiplying every x value by 3. If you wanted to do this, k equals y over x, right, to find the constant proportionality, right? So take any of these values. So you can take 1 and 3, 2 and 6, 3 and 9, 4 and 12, whatever you want. And let's just pick 3 and 9. The point 3 and 9. This is x and this is y. So if you pick the point 3 and 9, you get 9 over 3 and you get k equals 3. And there is our constant proportionality, and which happens to be our unit rate, right? When the triangle is 1, the sides are 1, what's our perimeter is 3. So notice that this 3 is quite important, right? It's our constant proportionality. It's what we multiply every x value to get the y value, and it's a coefficient here. Now we got to figure out if these points, right, are on this line. So if we continue, let me just create a table here. Right, so we know what the constant proportionality is. Every x value is being multiplied by 3. So this is x, y, this is the side of the triangle, and this is the perimeter. Well, let's write these points down. 1 and 4, 4 and 12, 10 and 30. Which of these points would be on this line? Well, when the side is 1, well, we got to multiply by 3 first of all, right? Times 3, times 3, times 3. 1 times 3 is definitely 4. So this point is definitely not on top of this line. No. 4, the point 412. With 412, if I were to continue this, 4 and 12, would that be on the line? Yes, it would. Look, 4 times 3 is 12, right? So this point is on the line. What about 10 and 30? Well, 10 times 3 is 30. If you have a triangle and all sides measure 10, wouldn't the perimeter be 30? So this works and this works. So these 2 points would be on because they are proportional. Okay. Yeah, that's that. Find the equation of the line. So right off the bat, just by looking, you can tell me it's not proportional. It doesn't go through 0, 0. It's a straight line, but it doesn't go through 0. Is there a proportional relationship? No, right? Does not go through the origin. Find the constant proportionality k. Well, we can't find it because it's not proportional. To prove or disprove the proportional, oh, I see. Okay, so we have the visual that says it's not proportional, but if we didn't have the visual, I guess that's what the question is asking. So let's get some points. Well, I have the point 2 and 4, right here. No, sorry, 2 and 24. This one right here. I'll write it right here. 2 and 24. I have the point 4, and I think this is 4 and 28. Yes, it is. I have the point 6 and 32. I have the point 8 and 36. Now, if this was a proportional relationship, whatever I multiply x, I should use the same value for each of these to get y. So 2 times, for example, 2 to 24 would be times 12. And if this was proportional, it also would be 4 times 12, 6 times 12, and 8 times 12. But you can tell that it's not. It's 4 times 7 to get to 28. 32 divided by 6, I mean, 32 divided by 6 is some ugly number, 5 and 1/3. So you can tell that it's different. So again, that's not what they really asked, but they actually asked you to find the constant proportion, to find k, right? So let's find k. So let's use the point 224. If you want to use the point 224 and you do y over x, you get k equals 24 over 2. And if it was proportional, everything should have been multiplied by 12. Let's take another point, 4 and 28. Well, if this was a proportional relationship, we should also get 12, but k equals y over x. K equals 28 over 4, which is definitely not 7. Notice that they're different. So there, we don't have to do 6 and 32 and 36. We already have 2. So off the bat, just by doing this, because k's are different, this is not a proportional relationship. Because if it was, we would get the same value for k for each of the points. Okay? Just out of the bat, what do we call that? That is your y-intercept. Okay, you need to, sorry, okay. Where are we? Find the equation of the line, find k in the equation line. What's the unit rate? Okay. Right. Proportional, yes, I can tell by the graph. It's a straight line, goes through 3 origins. So the unit rate is where 1, right? So where the unit rate, where does the unit rate happen on the graph? It's when x equals 1, y equals whatever value, right? So we have the point 1, and this is the unit rate. So, but the problem here is that let me put some numbers here that were skipped. 0, 2, 4, 6, 8. So the problem is that I can't tell from the graph what the y value is when x equals 1. Okay, I just can't. I'm not going to guess. So what we have to do is get some points. So let's get some points we can actually see. Well, I can see that when 4 and 12, I can see, right? This is a point that I can actually measure. 5, 6, no. Well, actually 6 and 18, sorry, I can do this. Which means I can do this. Well, this one, is it right at the half line? I can't do. So I have 2 points, which is more than necessary. So again, x and y, I'm going to put the point 4 and 12, and I put the point 6 and 18. We can really clearly see, right, that it's times 3, right, and times 3. So every x value is being multiplied by 3. Again, if we do this, k equals y over x, you can pick the point 4, 12, and just find the constant proportionality. We do 12 divided by 4, and k equals 3. So we know that every x value is being multiplied by 3. So if I go back here and put The numbers 1, 2, 3. Well, I already have a 4. So 1 will be times 3, which is 3. So this one here and this guy here, now I can tell you what the unit rate is, right? The unit rate is this, the constant proportionality is 3. So the unit rate is 3 points, $3 for one bracelet. That's my unit rate. Okay, what's the equation of the line? Sorry, we need an equation. Well, y equals what's happening to every x value is being multiplied by 3. There you go. That's the equation of the line. 9. Again, sort of a repetition. Total cost, so you go, what is it? You play 2 games, you pay 15. Let's put some values here. 1, 2, 3, 4, 5, 6, 7. What is this? Seems like 5, 10, 15, 20, 25, 30, 35. It says here that when I play 1 game, I pay $10. Let me create a table. Oops. So my X is games, represents the number of games that I play. And then the Y value represents how much money I used. All right. So let me start with 0. I play 0 games and I'm already down $5. I paid $5. 1 game is going to cost me 10. 2 games is going to cost me $15. 3 games is going to cost me what? $20. 4 games is going to cost me $25. Okay. What's the problem here? Well, first of all, we already know visually that's not proportional. It doesn't go through 0, 0. All right, now if you were to find k, I mean, it's just to prove that it's not proportional, right? K equals y over x. Let's take 2 points. Let's take these guys and these guys, right? So if I do that, so here's a point 110 and here's a point 215. I should get the same value for k. Do I? No, I don't. So for 1, I get 10, and if I do this here, y divided by x, which is 15 divided by 2, I get that it's 7.5. So obviously, not proportional. We already knew that, but now I have more proof. So, what does 0.5? How is it that I played 0 games? I'm already down $5. What would be an explanation in the context of this story? Well, it could be that I went to an arcade. Although I don't know if this is true. Yeah. What is it? What is that famous one? Dave and Buster's. So when I go there, you have to load your card, right? There's a little card that you upload your money, and that gives you credits. But that card is probably not free. So there's initial payment. I have to pay to have that card. So that might have cost me $5, right? To get the card, and then I put money in the card. So without even playing, I'm already down $5. Or I went to an arcade. I don't know, Chuck E. Cheese, but Chuck E. Cheese charges me an entrance fee. Do they? Do they charge you an entrance fee? No idea. But let's assume they did. So I went to Chuck E. Cheese. To get in, I had to pay $5. So I haven't even played a game, and I'm already down $5, and that explains our point 0. In the context of this situation. Now, I don't know if anybody remembered this because it's been a few days, but how do I find the equation of this line? Well, the one thing I know is the y-intercept. So when it's not proportional, the equation of your line looks like this, mx plus b. B is your y-intercept. Where does this line cross the y-axis? And it's crossing at 5, so I know this much. Right? Now, I need to find the slope. Now, allow me to erase this. So slope is also known as m. And how do we find m? M is a change in y values over, so we can write it like this, a change in y value over the change in x value. So to find the slope of this line, I need 2 points. Pick any 2 points. Let's pick the easiest 2 points. So let's pick the point 0, 5. Right here. And let me pick the following point, which is 1 and 10. So let me just take this first step. So y2 minus y1, x2 minus x1. So one of them is going to be your first point, and the second one will be your second point. So it doesn't matter who you pick, you get the same answer. So let's call these my ones, x1, y1. Let's call these the twos, x2, y2. All you got to do is plug it in. It doesn't get any easier than that. So y2 is 10, y1 is 5 over x2, which, sorry, x2 is 1, sorry, that's correct, and x1 is 0. 10 minus 5 is 5, 1 minus 0 is 1, and 5 over 1 is just 1. So my slope is 5. So I can come here and write y equals 5, because now I know what the slope is, right? It's positive 5x plus 5. This is what you've been doing with the visual patterns in a way, right? So if you think about this visually, right, just like one of the patterns that we've done, you could have said the plus 5 is what's happening in every term. Plus 5, plus 5, plus 5. There's five stars. 1, 2, 3, 4, 5. 5 stars here. Right, every term has that 5 stars, and then this, okay, would be what you're multiplying the term by. Okay, let me erase that. So let's prove it. Okay, let's prove that this actually works. So let's take this point right here. This point is 4, 25. So what does this mean? It means that when x is 4, so when you play 4 games, your y, which is your output, it shows that you spent 25 bucks. Well, plug it in. Well, when x is 4, so y equals 5, and the number of games you played was 4, and then $5. Well, y equals 5 times 4 is 20, plus 5, and y equals 25. Is that true? Yeah, look. When you play 4 games, your total cost ends up being 25. It works. You can play around and see if it works for other ones. But now that I have this equation, y equals 5x plus 5, I can ask, what about if you played 28 games? How much would you spend? Well, here's my equation, 5x plus 5. That would be the same thing as me asking, what is it, the 28th term? How many stars, cubes, squares would I have? Well, plug it in. So y equals 5 times 28 plus 5. Y equals, I have no idea. We get 140 plus 5. So my total cost would be $145. So if you happen to go to Chuck E. Cheese and you play 28 games, every game was $5 for some reason, you would end up spending $140 for the games, and then the $5 is your entrance fee that you paid. Okay. All right. We'll definitely do more slope next week. Okay, getting a little repetitive here, no? Again, proportional. I already know it's proportional. We want the unit rate. Well, on the graph, the unit rate's right here. Look, oh, this one is easy. We can actually find it without a problem. So when one practice, right, x represents the number of practices. In one practice, the distance is 2 miles. So if you write it as a fraction, you can write that 2 miles as a unit rate for every one practice. Okay. Can you find the constant proportionality? Well, if you know the unit rate, here is also, this guy is also known as your constant of proportionality. Okay, so if you want to, so let's grab a few more points, 2 and 4, 3 and 6, and if you create a table, maybe that's easier for you to see. Let's take the values of x, 1, 2, 3, and let's even go to 4. So when x equals 1, y is 2. When x equals 2, y is 4, 6, and 8. So what's happening to every x value? Change colors here. Times 2, times 2, times 2, times 2. So if you had 48 practices, well, that's not a big deal. Times 2, so it would be 96 miles, etc., etc. So what's the equation of this line? Well, the equation of this line is y equals, well, that's the unit rate's my constant proportionality as well. as I know that, it makes my life very easy. So I'm multiplying every x value times 2. Oh, last question. Here's the equation y equals 2.5x. It's proportional. It says it represents a proportional relationship. Create a table, graph it, be sure to label everything. All right, so let's create a table. X and Y. Use easy points, right? Just nothing. I'm going to use the first 5 points. This is my X, this is my Y. So at 0, so if I use the equation y equals 2.5x, I'm multiplying every x value by 2.5. So if I 2.5 times 0, y is going to be 0, so that's 0. When x equals 1, y equals 2.5x. Let me, y equals 2.5 times 1, y equals 2.5. So, right? 2 times, and then obviously, so it's times 2.5 times 2.5 times 2.5, which gives me 5, times 2.5, which is going to give me 7.5, times 2.5 is going to give me 10, and then times 2.5 is going to give me 12.5. So there, I have enough points to create a graph. So let me label this 1. So here, 1, 2, you know what? We have room, right? We're not going to that. So let me spread them out a little bit. So 0, 0. I'll make every 2 boxes 1 unit. So 2, 3, 4, 5. Going up and down, I'm going to go by 2.5. And again, 0. So 2 boxes can be 2.5. This can be 5. It's going to be, so again, as long as your intervals here are the same, you're in good shape, right? Every 2 is 2.5. And then now we get to plot the points. So I know 0, 0. 1 is 2.5. 2 is 5. 3 is 7.5. 4 is 10. So again, I don't know. Let's create a story. Every apple is $2.50. No, not every apple. Every it's $2.50. Every. Oh, I just bought it today. What's that thing with a lot of red seeds inside? I forgot. You know what? Bottle of soda. Okay. Bottle of soda. 20 ounce. Okay. So 1 bottle cost me $2.50. 2 bottles cost me 50. 3 bottles cost me $7.50. 4 bottles is $10, and so on. So this would be represents the total cost, and y x would be the number of bottles of soda. Okay. Yeah, that's it. This is as simple as it gets. Okay. Am I missing something? Create a table, graph it, be sure to label everything. Okay, sorry, I did forget something, so I'm gonna definitely, in the context of this, right, just make that there, put an arrow here to continue to say that it goes on forever. Here are some points. My label, I gave it a title, label my x-axis, my y-axis, and here's the name of my